Okay, so we've looked at the compound angles and drilling, and we've looked at milling the corner off of a block and the angles of rotation and tilt for that. Today we're going to look at finding the angle of the corner or intersection of compound surfaces. What do I mean by that? Well, what we're going to look at is this. Try that a little bit better here. What we're doing this time is we're taking this block and we are going to cut off this surface at an angle like this. So I put those back in. So we're milling one of the edges off at an angle. But then we're going to come back and we're going to mill a second edge off at an angle. Like that. You can draw that. Here, I'll show you how to do that.
What parts are you going to draw so we know ahead of time? Yeah.
Here, I'll draw it out for you a little bit neater. There, how's that? If you want to, you can draw in that back corner. There. It might take, you want me to pause for a second so you can try to draw it better? Okay. So what we're concentrating on here is just this edge right here where the two surfaces intersect. And what we're finding about that edge is if we look at that corner there in particular, magnifying that corner there, or that edge comes in. Here's that edge coming in. Well, if we think of this little line here being the line directly underneath that edge, this angle right here is our angle of rotation. That's how far we would have to rotate that part to put that edge in line with our machine's axis. This angle here is the angle of tilt. That's how far we would have to tilt it to put that intersection flat with the floor, level with the floor. So what we're doing is the same type of thing. We're rotating this part to put that edge, this edge right here, level with the floor and in line with our machine side to side so that we can polish the edge or round it off or whatever we need to. You know, maybe we're going to round it off for stress relief or something like that. So what we're concerned with here is a little bit different than our pictures from before. So if we're looking at this from the one side, and this from the end, so think of this as being a front and a right end view. We could have, maybe we're given that this here is, let's go with millimeters instead of centimeters to make it easier on us. Let's say that this is 24 millimeters. This here is 38 millimeters. This down here is 60 millimeters. And this down here is 48 millimeters. Let's go 40 millimeters. Make it easier on us. Well, now what we're looking for, none of those are the dimensions we want. The dimensions we want are this one, and we need this one here, the depth. Now I'm going to go ahead and give you that depth is 36 millimeters. What's this dimension here have to be? 16. Good. The 40 minus the 24. How about this one? 22. The 60 minus 38 is 22. So we have those dimensions. So really what we're working with is still just a box that looks like this. And the edge goes corner to corner. And we're looking for this angle of rotation. This here is going to be our angle of tilt. We know we were given that this was 36 millimeters here. Oops, 36, not 63. We calculated 16 millimeters here and 22 here. So now our calculations are exactly the same. How do we find R? It's going to be an inverse tangent. What's the opposite side? You got it, 16. We're going to be looking at this triangle with the right angle there. This is 16 over 22. Good. Giving us 36.03 degrees. That's our angle of rotation there. To find our angle of tilt, it'd be nice to have the length of that surface. So let's go ahead and find the length of that surface. That's just going to be the square root of 22 squared plus 16 squared plus 36 squared. Which gives us 45.12. We'll go 122 millimeters. Is the length of that cut, or length of that edge, I should say. It's not really a cut this time. From that, now we can find T. Because from T, we know the opposite side here, which is 36. We know the hypotenuse. If this is our right angle, we know the hypotenuse, which is the 45.122. And opposite of our hypotenuse makes sine. So sine of t equals 36 over 45.122. So that t is equal to the inverse sine of 36 over 45.122. So 52.92 degrees is my angle of tilt. Make sense? Sort of? Okay. Well, another way that this can be given to us would be like this. Those are dotted lines because that corner is really missing and it's not there. But you could be given that this here is a 36-degree angle and that this here is a 42-degree angle and asked to find the angle of rotation and angle of tilt. Well, just like before, when we're given just angles, we pick a thickness or a depth here. We're going to pick that to be 10 millimeters again. From there, we'll find these dimensions here and here. We'll pretend my artwork doesn't totally suck. So if this here is, we call this X and Y, this will be X and Y, and we just chose this to be 10 millimeters thick. We're looking for R and T. Now again, the lengths here now mean nothing, but the angle should still be the same. So from the 10 millimeters, we find x, because the tangent of 36 degrees should equal 10 over x. Cross multiply and divide, it becomes 10 divided by tangent of 36, which is 13.764. Over here, same setup. Tangent of 42 equals 10 over y. And again, we put this over 1, cross multiply and divide. We get 10 divided by the tangent of 42. 11.106 millimeters. So we have all those dimensions. Now we come over here. This is 11.106, 13.764. We can find r right away. R is the inverse tangent of 11.106 over 13.764. So inverse tangent 11.106 divided by 13.764 gives us 38.900, basically 38.9 is our angle of rotation. For our angle of tilt, we still need to know this length. Even though it's not going to be the correct length, it's going to be the length that we're going to use in our calculation. So that's going to be the square root of 10 squared plus 13.764 squared plus 11.106 squared, which will give us a theoretical length that we'll use there of 20.317 millimeters. So then our angle of tilt, T, is going to be the inverse sine of 10 over 20.317. So inverse sine of 10 over 20.317. 29.49 degrees. What do you think? Good stuff? Try to contain your excitement. On page 416 through 418 of your packet, it is numbers 1 through 14.